Welcome and thank you for joining me in this part 2 of our Network Foundation series. In this video, we're going to go through some networking concepts that you're going to need to know as we move through the series. Now, this is by no means a deep dive into these concepts, but they will give you the fundamental understanding you need to kind of make sense of what we'll be talking about in the next few videos. We would also encourage you to do some additional digging to deepen your understanding, as that is ultimately the best way to learn. We'll leave some links in the resources section below this video, as well as in our companion blog post on our website, so that you can, on your own volition, dig a little deeper into these concepts if you feel it necessary. Now, if you're a networking veteran, this content might be a little bit basic for you, so feel free to skip this video. However, one of the things that helps the community is to make sure that we bring along the folks who are less technical and where these concepts might be new. So if you want to watch and provide some additional context or comment, that would be welcome as well. All right, so let's talk about our first term, and it's the term network. So what is a network? A network is simply two or more devices connected to one another in a manner that allows them to exchange data. So in this example here, you see we have three devices, three computers in this case, and we've got arrows representing physical connections between these devices. Now, in this scenario, each device would need to have two network connections, or what we call interfaces, which we'll talk about next. But basically, a network is just any devices connected together exchanging data. There are typically three categories of connections, types, we'll say. Physical, for example, a cable. You can also have a wireless where there are no cables, but the devices are still connected to one another and exchanging data through a radio signal. And then you can also have what are called virtual connections, where in software there are elements that mimic physical connections and they also exchange data. So those are the three typical types of connections. Okay, so we have these different types of connections. And then the other element or other aspect of a network that you need to be aware of is that the network has a boundary. Okay, in this example, the boundary happens to be the connections between these three devices. And the boundary basically indicates that these three devices are identifiable to one another directly. If we had another computer out here, for example, okay, and even though it's like, let's say, physically right next to this other one on a table, for example, because it is not connected to any of the other computers, it is not part of or inside the boundary of this network. Okay, pretty simple concept. So there has to be a boundary to the network. We'll talk more about the different types of boundaries, but basically those are the two elements. It's devices connected together in some way, exchanging data, and they're defined by some sort of boundary. Could be physical, virtual, etc. Now, let's talk about the next concept here, and that is the concept or the term interface. Okay, when we say interface, it's referring to the port to which the connection is established. As noted before, this could be a cable of some sort, a wireless signal, or some sort of software-defined or virtual interface. But here's an example of a physical interface, set of interfaces. Now, this device right here has multiple different interfaces. These here are interfaces to plug monitors into, or it's HDMI, but we're talking specifically for network interfaces. This is a network interface. This is a network interface. And this is a network interface with a cable connected to it. Okay, so that is what an interface is. Now, with wireless interfaces, you might have, for example, this device has the ability to have a wireless interface. You can see right here, there's a place for an antenna. And then the actual interface would be a little circuit board on the inside of this device that is controlling the wireless signal sending and receiving and then processing. And that would be a wireless interface. And then we'll talk more later about virtual interfaces, but basically the concept here is that it's a medium through which the data is exchanged, okay? The next term we're going to introduce is the term Intranet. Here's an example of what an internet is. It's a collection of many networks connected together, allowing the exchange of data. And the internet specifically resides outside of your own local network. So for example, let's say this is your network here, and we have a device called a router, which we'll talk about in a couple of terms, but this router defines the boundary for this network. And then outside of that router, you have all of these other networks, and they could be local networks, another business or a home or something. But the internet is the part that connects all of these other networks together. And so the boundary of the internet can be confusing at times if you have multiple networks that are local. So for example, down here, we have an example of, or a depiction, we'll say, of many local networks. Sometimes people get confused about where the internet boundary is. Just know that the internet is the group of networks that's outside your local network. The next term to introduce is intranet. Okay, so whereas you have these this group of networks that are outside of your local boundary or your local network, you can also have a group of networks that are inside, and that would be considered your intranet. Okay, so it's a group of networks, a network or group of networks that is local to you and not part of the internet. Now, this introduces the idea that you can have more than one local area network, okay? So just know that it's possible to have more than one network that is close to you and that is not part of that group of networks. Outside your immediate network, we call it the internet. Now, you may not have heard of, you've heard of internet, but intranet may be a concept you've not heard of. But usually those refer to the boundaries or the proximity of these networks, right? The internet is outside, the intranet is inside. There, we're just talking conceptually about networks or groups of networks. The next two terms we're going to introduce more specifically, and we'll kind of zoom in here so that we can talk about them, but you'll hear or maybe even see these two terms, WAN, which stands for Wide Area Network, and LAN, which stands for Local Area Network. Now, they are both somewhat synonymous with internet. So WAN is typically considered to be on the internet side of things, and LAN is typically considered to be on the intranet side of things. What these two terms add is they begin to discuss the physical aspects of the internet and the intranet. WAN oftentimes refers to an actual interface that is on the internet side of your network boundary. And LAN refers to the interface or interfaces that are on the intranet side, so the local area network side. The confusing part there is that people use these terms interchangeably. When they say LAN, they mean the group of networks or network that are local to you, but it can also mean, and is often referred to as, the interface that is on that side of the table. So those two terms will become important as we start configuring devices and setting up networks. So again, the internet is the group of networks outside of your local network. The WAN is typically referred to as the interface on that side of the equation. Intranet are the network group of networks that are local to you, and the LAN are the typically referred to as the interfaces that are connecting that side of the equation. Okay, now we're going to start talking about devices here. The first device we're going to talk about is a device called a switch. If you remember back in our network definition, we had this example where these computers were connected directly to one another. And the implication here is that if you're going to grow this network, you have to add an interface for each device you want to talk to. So let's say we add another computer here, let's say maybe down here, this is going to get kind of funky, but then we need to add another cable for that. Then we need to add another cable for this. Okay, then we got to add another cable for this. And you can see it's going to get very unwieldy after a while, because every computer you add, it exponentially increases the number of connections you need. Okay, and so to deal with that, we introduced the device called a switch. So what a switch does, let me turn that off, is it acts as the intermediary so that any device you want to connect to the network can simply plug into the switch, and the switch connects everything together. So in this example, we have a switch here. It's got multiple ports. We have a computer connected to this switch, another computer here connected to the switch. We've got an access point, which we'll talk about in a second, connected to the switch. And then these wireless devices connect through the access point, which is connected to the switch. And so what the switch does is it allows us to connect multiple devices together without those devices having to have a port or an interface for every device it wants to connect to. As long as you have enough ports on the switch, all the devices connected to the switch or group of switches can potentially talk to one another. All right, the next term we're going to talk about here is, or next device, sorry, is something called a router. So a router is a device whose job is to connect two different networks together. As you saw in the previous definition, it's designed to transfer or route data from one network to the other. Remember, we have boundaries on these networks that define them, and the boundary tells the devices which devices are connected on the same network. So in order to get from one network to another, we have to have a device in between them that basically is connected to both the networks and knows the details about each network so that it can pass traffic from one network to the other. And that's what a router does. It just routes traffic between two or more networks. And on the internet is basically made up of just a bunch of routers that are routing traffic between networks. And on an intranet, you also have to have a router that routes traffic between all of the local area networks on the intranet. And so for the most part, though, you're probably used to the term router when it comes to getting to the internet. And so basically all that's doing is it's taking data from your network and routing it or passing it to the next network that it's connected to. Now, the other key point here is that a router can only route traffic to the networks or between networks that are directly connected to it. You might ask, well, how would it get data to a network that's not directly connected? Well, a router also has information that tells it, hey, if I'm not connected to the network that this data is intended for, I'm going to send or forward the data to another device. And that other device is a router that router is connected to. So that's how you can get multiple routers connected to one another, and they can route traffic through networks by either being directly connected to the network or having another router that it can send the data to that can then route the traffic forward or route it on to the next router, or next hop is the term there. Okay, and by hop it just means the next router in line to get to the network that it's destined for. Now, routers also come in various sizes and shapes, including being combined with switches, as mentioned in the switch definition. The main difference between a router and a switch is that the switch connects the devices together to form a network, and the router sends the data between those networks. Okay, so that's the key difference between a switch and a router, is that the switch forms a network and the boundaries, and then the router, which can be part of that network, forwards the traffic between networks. All right, the next and final device for the moment that we're going to talk about is what's known as a wireless access point. Now, a wireless access point is a device with the functionality of a switch, but the interface instead of being physical ports that cables plug into, is a wireless antenna connected to a circuit board that allows multiple devices to connect to the network via a radio signal. So think of an access point kind of like a switch. It will typically have at least one physical interface so that it can connect to the switch, but it's going to be like an extension to the switch, to the regular switch, that converts the switch into a radio signal. I know that they're probably conflating some terms there, but just think of the access point as an actual device where its job is to convert the switch connections into a radio signal so that multiple devices can connect to the network through the access point via a radio signal. Now, the most common misconception, if we zoom back out here to our router example, is that in your home network, you're going to have a device that combines all three of these devices. So a switch, an access point, and a router all into a single device. And I probably should have an example, but you know what I'm talking about. And so you'll hear people say, I'm connected to my Wi-Fi, right? We see this in the support queue all the time is if you're at home and you're asking a question, hey, can you get to the internet? And people will say, well, I'm connected to Wi-Fi. Technically, that just shows that people conflate the internet with their Wi-Fi. And so it's very important as we move forward, if you're a beginner, that you need to separate out a switch from an access point, from a router, even though you're probably used to all of those things in a single device. So hopefully that makes sense, that now you understand that your home router is actually three devices in one. It's a switch. You know, if you look at the back of it, it might have 4 ports that are yellow and they say LAN on them. That's the switch. Then it might have a WAN port. Now that indicates that if you have a LAN port, if you have LAN ports and WAN ports, that means that that device is a router and it can forward traffic between networks. So on the WAN side, you're connecting to the internet provider's network, and on the LAN side, you're connecting to your own local network. And then the wireless signal inside that is being broadcast is again an access point that is part of these other two functions. And so that's the main reason we just talk about these three devices, is that you will want to conceptually separate them all into separate things so that as we build out our network, you're not confused about, internet versus Wi-Fi versus a switch. Okay, now we're going to briefly go over the very basics of IP addressing, and I mean basics. However, here is where we will definitely encourage you to become more familiar with IP addressing. We've, again, found some fantastic resources that do a little more deep dives into how all this works at the very base level. Hopefully, after this video, you'll have a really sort of enough of an understanding to move forward. What you're looking at here is a particular version of IP, or Internet Protocol, address, and specifically it's the version 4 of that. Now there is another version 6, which adds some complexity conceptually, and so during this video series we're going to mainly be working with IPv4, the version 4 of this Internet Protocol network addressing, and so we'll define that here, but again, we would encourage you to start looking into IPv6. Although you don't see it very often, it is something that they are trying to push on us. So the first element of an IPv4 network address is the IP address, or the actual address that a device has. What it is a unique identifier on a network that denotes the address or destination to send data packets to. Comes in 2 different flavors, as we mentioned, version 4 and version 6, and they are referred to as IPv4 and IPv6. So you'll often see this depicted here. Let me actually add that. But that IPv4 looks like this, and IPv6 looks something like this magically. And so you can see those are very different. So we're going to not talk about IPv6 for now. We don't want to throw too much at you. And in the series, we'll be mainly using IPv4. So I'm going to go ahead and we'll just get rid of this for now so it's not distracting us. The characteristics of the IPv4 address are that it has 4 sections. You can see here 192.168.1 and 10. That's 4 sections. Each of these sections is separated by a period, so you have 3 periods. Now this denotes an octet. Just know that the 4 sections always have to be there. Every IPv4 has to have 4 sections separated by 3 periods. And the numbers that are in each section can be from 0 to 255. Okay, so you can see each of these numbers does not exceed 255. Additionally, there can only be one of the same IP addresses on a network. Okay, so they have to be unique on the network, meaning you can't have 2 devices with 192.168.1.10. You'll have a problem because then other devices won't know where to send the data packets. So it can't go, the same data packet can't go to 2 devices simultaneously. Well, technically it can, but it can't go to 2 different devices with the same IP because it won't know how to distinguish between them. So it has to be unique on the network. And then finally, this IP address is assigned or attached to an interface. The IP address is IPv4, that is 4 sections. It's unique. The numbers are between 0 and 255 in each section. And this number gets assigned to an interface. Now this next piece of information, the subnet mask, I like to think about it in terms of the network boundary. Okay, and so what it does, the reason it's called a mask, is it covers up this first octet, covers up this first octet up here. The second one covers up, and we'll talk about what I mean specifically here in a second, but the second octet covers up this octet, and the third one, the third, and so on. Now, when we say covered up, what we mean is that these numbers define the boundary between the network boundary and the devices on that network. So what does that mean? In this example, this 255 covers up the entire 192. And so we can assume that this is the first part of the boundary of the network. This 255 covers up this 168. Okay, so now we add to this initial boundary, this second octet is also part of the network boundary. And when we say it's part of the boundary, what that means is that these numbers here cannot be used as a dynamic assignment to a device. And we'll get to that with this last 0 here. And then this 255 adds this 1 to the network boundary. So when we say 192.168.1 is the network, what we mean is that's the boundary of the network. Now everything after that, this 0, because it's 0, doesn't cover up anything, which means that all of the numbers in this last octet, so from 0 to 255, are used as part of the network devices or the things on the network. Hopefully that wasn't too confusing, but this is a necessary part to define the boundary that this IP address lives in. The gateway, as we talked about before, refers to the router or routers. You can have multiple gateways on the network. But there's always what's called a default gateway. It's just default gateway. Sorry about that. And that's an IP address on this network. You can see, remember, we can't use 0, but the first available IP is 1. So we're going to use 1 as the gateway. And think of the gateway as the front door. It's the door you go to get out to the other network. So the default gateway is the path that you can get to other networks not in the network boundary. Okay, and this last piece of information here for configuring your computer's network interface or a network interface is something called a domain name service server. So DNS refers to 2 things. It refers to a domain name server and a domain name service. In this case, we're distinguishing the DNS with the term server behind it. So that means this is domain name service server. But sometimes you'll see just DNS and then an IP address, and that refers to the domain name server. And you assume that means that's the server or the device that is performing the following function. What DNS does is helps users not have to remember IP addresses, and does this by keeping a database of domain names, for example, staple.io, and the IP addresses that tell computers where to send data when they want to send it to those domain names. It essentially acts like an address book that's keeping track of names and addresses. All right, think of it like the post office, or really an address book is the best analogy. So we introduced another term there that you're probably familiar with, but let's just talk about it real quick. The term domain name. And in IT or in networking, the domain is basically analogous to a network. And so, for example, you can have a domain name that has a TLD, okay? So the TLD is the domain that is the top level domain. It's just a name that points to a network. That's called the top level domain. You might even hear that term in various circles. Now, the top level domain, for example, com, an example of a top level domain is domain com. You see that everywhere. That is what's called a top level domain. Other examples, net, that's a top level domain. IO, the top level domain. They refer to names that are the start of the network. And again, there are public TLDs, and then you can also have private TLDs, which are basically made up. They can be whatever you want. And technically, they can be the same as public domains. And then you can use a DNS server to create a custom database that points the devices that are asking the DNS server questions to other destinations, different IP addresses. That's what a TLD is, a top-level domain. Okay? And then you have everything before the top-level domain is the rest of the domain name. And you can have multiple domain, and then you can break that down into a subdomain. So basically, you have a TLD, which is the first or top level, and then you have some sort of domain name, and then you can have a subdomain name, and you can keep on going forever if you really want to. But as you get more sections, it becomes harder to remember. And so typically, you're going to stop somewhere between 3 and 4 subdomains. The other term you're going to hear is something called an FQDN. And what an FQDN refers to is fully qualified domain name. And all that means is the entire thing, the entire domain, including the very first one, which is typically the device. So this gets you, the FQDN is the entire domain that gets you to the destination. So in this example, let's say the device.sub.domain.tld points to 192.168.1.10. That name is referred to as the FQDN, which you may see throughout the series. So hopefully that makes sense. One other type of address we're going to talk about is something called a MAC address. You're going to see this everywhere as we configure things, so we need to talk about it here briefly. So a MAC address is another type of unique identifier, but the difference between a MAC address and an IP address is that the MAC address refers directly to the interface that we're assigning the IP address to. For example, each of these devices on the network is going to have a MAC address, and it's burned into, if you will, although in some devices, in virtual interfaces, they can be altered. And actually physical interfaces, you can do what's called MAC address spoofing. So you're basically in software changing the physical interface MAC address. But the MAC address is a 12 character, 6 pairs of what's called hexadecimal. So 0 to 9 and I think A to F or something like that. Combination of numbers and letters. As an example, this interface here has a MAC address of 0232C3014E2E. And then this IP address gets assigned to this interface. The difference typically between the IP address and the MAC address is that this number, 192.168.1, can be moved, right? Like we could move this over here and this over here. And now this device has the same MAC address, but now that MAC address is represented by this new IP address. So those IP addresses can move to different devices. They still have to be unique, but they can move around. And typically, the MAC address stays with the interface that the IP address is assigned to. This is how switches determine where the physical connections are that the IP addresses are associated with. So, for example, this switch keeps track of the MAC addresses and the ports they're connected to. It has a little table or database in its software that says, okay, the interface that this computer has that's connected to the network is identified by this 4E2E MAC address, and it lives on port 1. In addition, this device up here that has this MAC address lives on port 2. This access point that has this MAC address lives on port 3. Oh, and by the way, I am also seeing on this port, in addition to the 2BE, because remember the access point is like a little switch, I'm also seeing 4E2E over here on the same port. And so and the IP address, and if the data is destined for this over here, I'm going to send that data to this port that this device is connected to. And then this access point has a similar function where it says, oh, okay, here's the radio signal that this data needs to go to, or the connection here. Okay. But anyway, that's a MAC address. It's very important on the physical side of networks to determine where these devices are actually physically residing in the network. Okay, analogy time. Now that we've introduced the main components for the IP addressing on a network, let's use an analogy that I was taught that helped me sort of put it all together. I'm going to see how they're all related. So imagine a street that happens to be a court. We'll call it East LAN Court. As you can see, here it is right here, East LAN Court. It goes from here to there. Along the street, you have a few houses, and up ahead, you see a gate that is your only route out of the neighborhood. At that gate, the street ends, and when you go through the gate, you're on West WAN Boulevard, which just happens to be a public street. Now, obviously, the houses all have addresses on that street. For example, 200 East LAN Court, 201 East LAN Court, etc. And for purposes of this analogy, we'll also give the gate an address of 1 East LAN Court from the perspective of our neighborhood, and an address of 147 West WAN Boulevard from the perspective of the public street. Let's say my friend Henry lives at 207 East LAN Court. There he is, chilling out in his house. It's an orange house with an orange driveway, and I know it's Henry's house. That's the domain name I gave it. I know that the IP address on the network street, and I can distinguish it by its unique physical appearance MAC address. I can also get a message directly to Henry's house without having to go to the gate, because my house, 205 East WAN Boulevard, is on the same street, aka network. So I could say, hey, I'm going to go to Henry's house, and I can get there and send him the message. But because he's on the same street, I can send the message directly to him. I don't have to take it to the post office and have them send it. It would be a waste of money. So in this analogy, the house number is the unique part of the address. Okay, so that's like the IP address. So 201 or 200 in this example is the IP address on the network East LAN Court. So East LAN Court is like the subnet here, Subnet Mask, which defines the boundary of this. And the unique number between the addresses is the actual IP address. Here's our gateway over here that we can get out of this neighborhood through. And this gateway is responsible for managing the traffic back and forth, routing the data back and forth. There are two more terms I'd like to discuss that we will be using very shortly here in our first couple of videos. The first one is something called a dynamic host configuration protocol. So if we were to look at this analogy here, you're typically not going to change the address of these houses, right? They're going to stay the same. 200 is going to stay 200 until the house gets torn down, or until they change the whole network scheme of the street. That would be what would be considered a static address, meaning even though the number is arbitrary, it's been statically assigned, meaning we've determined that this house always gets this number. That's known as a static assignment. And when you're configuring a network for important devices, like houses that aren't changing or moving, you probably want to statically assign. But what if this side of the street had a bunch of spots for campers? You know, these people have families. You know what they say about families, after 3 days, they are a lot like fish. What if we had one side of the street that allowed family members to bring campers and they could set up their shop temporarily? Maybe they're there for a week or whatever, and then they leave. We would need a way to assign the addresses or a set of addresses to those temporary devices that are coming and going on the network. That is what dynamic host configuration protocol is for. So I'm not going to draw this, so hopefully my explanation makes sense without the visual, but let's say Henry's great uncle, long lost uncle from Schwami, New York comes. I don't even know if that's a real place. And, Henry's not too fond of him, but hey, it's family. Sure, we're coming for Thanksgiving. He's like, okay, come on in. And they arrive, they set up shop, and we give them the address because maybe he's here long enough, he wants to have something from Amazon shipped to him. And this analogy is getting silly, but we're going to give him the address of 220 East LAN Court. So he sets up shop, his little camper's here, and for the week that he's here, we're giving him address 220. That's the spot that he gets, and we have a limited space, so we're going to limit the number of IP addresses or temporary addresses that we're going to give out. Let's say it's just going to be from 220 to 230. So that gives 10 spaces that you can sort of dynamically come and set up shop for a short period of time. And then once that device leaves, that IP address 220 or the address gets put back into the pool of available addresses to be handed to my uncle, who I haven't seen in 3 years or whatever. So that's the job of DHCP, is to hand out all of the IP information. So this detail, it dynamically gives any device that enters the network an IP address, a subnet mask, a default gateway, and a DNS server or servers at the very least. Now there's some additional information it can hand out, but that's not relevant for our understanding at the moment. DHCP, Dynamic Host Configuration Protocol. All right, now the last term and concept we'll be discussing is something you'll see throughout this series, and it's known as a VLAN, or a Virtual Local Area Network. VLANs are a way in software to create a separation between multiple local networks. So think of them as like side streets in our analogy. They are connected to the same larger network, but separated logically from it. They have all the same characteristics of a normal network and reside local to us, but they have different addresses and are technically a different network. They clearly run over the same physical infrastructure, which is why they are called virtual local area networks. So think of it this way: if you've ever entered a street with a sign that says no outlet, and you go down the street, and as you go down the street, you encounter several side streets, right? With different names, different houses. They're technically connected to the street you're on, but they are their own thing. They're basically, the side streets are like VLANs, okay? Now, the only other thing to note is about VLANs is the way that you define them in software is via what's called a VLAN tag or a VLAN ID. And the VLAN ID is a number between 1 and 496, technically. If we were to go back up to this network up here, this is a network that is not a virtual local area network. It's actually, your default network. Behind the scenes, it actually has technically a VLAN ID. It's known as what's called the default VLAN. And almost all devices, I don't know of really any, the default VLAN is VLAN 1. Okay, that's the default VLAN, the first VLAN. And then from there, typically you would give a VLAN ID to the next VLAN, and some people do it in order. So you start with the default VLAN of 1, and then the next VLAN would be 2, and then 3, and then 4, etc. Or sometimes they'll marry it with the IP scheme, and we'll kind of go over that in a little more detail. But just know that a VLAN is like a little virtual side street, if you will, with its own networking setup, network address setup, but it is connected logically to the physical network. Now that we have a basic understanding of key networking concepts, there are a few tools we'll need in your tool belt for testing and verification purposes as we build out your network. All right, now for each of these tools, we'll give examples in each of the 3 main operating systems so that no matter which OS you're using, you will have a basic foundation on how to perform these tests. So let's look at a few built-in command line applications for each operating system. In Windows, the built-in applications include the command prompt or PowerShell. In Windows, this is a Windows 10 operating system, but it works similar in Windows 11 and Windows 7. You're going to click on the Windows icon, and let's first look at the command prompt. If you just start typing command, you'll see one of the options is command prompt. And this is the command prompt. Looks very scary, a lot of text, not too many buttons, but this allows you to do things like, for example, perform our first test, which is how can we quickly find the IP configuration for the machine that we're on. For example, this workstation here. That's a simple command in Windows. It's IP, stands for Internet Protocol, config, configuration, then a space, a /, and the word all. This is going to list all of your adapters or interfaces on the machine. Some of them are going to be virtual, as you can see here. This is like a software interface. We can very quickly see that Ethernet adapter is here, and it has an IPv4 address. Okay, so this is most likely the one that we want. If we look at the other ones, we don't see anything similar to that. All right, and here we can see all sorts of information. We can see the descriptor. In other words, if we were to look in Windows, what the label looks like. Here is the MAC address, also known as a physical address. We have the IP address, the subnet mask. We can see that this Windows machine is using DHCP for its interface. Here's our default gateway, our DHCP server, and the DNS server. Now, what you can see here is that all 3 of these servers, the default gateway, the DHCP, and the DNS server, are all the same device. That's an indication that you're using a router that has all those features combined into it. Okay, maybe with the exception of a switch, but it's performing all of those roles that we discussed earlier. Okay, that's Windows command prompt. Now we can also use a tool called PowerShell. And if we run that and zoom in, we can use the same commands in PowerShell as we did in the command prompt. So if we type ipconfig all, we get the same result. All right. Now we'll keep those up and let's go back to our Linux environment or our presentation here. In Mac OS, you're going to use a tool called Terminal, and it looks similar to this, where you have a terminal and you might have a user or something like that. And for our first tool, the IP configuration, it's a 2-step process that we're going to run. The first command we run is ifconfig, and then a vertical bar, the word grep, and then a string inside of a quote, single quotes. Okay. What that does is it results in this output. Essentially, what we're doing here is we're saying, give us the interfaces that are up and have a network IP address configured for it. And so in this example, it's returning a few interfaces, but the one we want here is the one with the IPv4 address. And you can see that EN0 is the only one with the IPv4 address. Now, once we get the name of that interface, we can run our second command, which is ipconfig, get packet, and then the name of that interface. And if we see what that returns over here, you can see I ran this command and it gives us a bunch of information. But again, we're looking for the YI address. Here's our address on this machine. Here's our DHCP server identifier. Here's our subnet mask, our router, the domain name server, so that's DNS server, and a few pieces of other information that we don't care about at the moment. All right, so that is Mac. Now, If you're on a Linux machine, you're most likely not watching this video, but we'll go ahead and show you what that looks like in case you want to switch to one of the best operating systems on the market, the free market. It's also a two-step process. Now, of course, there are other ways to accomplish this, but the command line is a very quick way to do this once you get the hang of it. It might be a little time invested to learn, but trust me, long-term, the CLI or command line interface is where you want to be. So here we're going to type IPA, and then we're going to grep again. And instead of the 8863 \vertical bar inet, we're going to just type up \vertical bar inet. So this machine happens to have quite a few interfaces. And you can see there is an interface titled ENP6S0, and that has our IP address on one of our networks. So let's type our second command. Now in Linux, there are a few different network managers, is what they're called. And this Debian operating system happens to be using one called Network Manager. And so NMCLI stands for Network Manager Command Line Interface. Dev is a reference to a device. So it's just a generic term in Linux that basically we're saying use the Network Manager CLI on the device. And what we're going to do on the device is we're going to show the device ENP6S0. All right, now we can see we've got a bunch of information. It gives us our DNS servers, our default gateway, our IP address, MAC address, all the things we might need to troubleshoot. Okay, so that's the IP configuration check. All right, the next tool is a tool called ping, and its job is to check whether a destination is up or not. It does this by sending out a packet and asking for a response from the endpoint that it sent the packet to. It includes some statistics about how quickly it got there and back, and some other details that we'll go over in just a second. So here we are in Windows, and we're going to type ping and then our destination. And the destination can be an IP address or it can be a name. So we'll do both examples. Here we're pinging our gateway to see if we can get to the edge of our network. Great. That tells us a couple of things. One, that we sent 4 packets and we received 4 packets. It took less than a millisecond. And the TTL, which stands for time to live, is 64. And what that means is if this packet were to go to 64 routers or 64 hops, the 65th hop is going to discard the packet. That ensures that this packet doesn't travel forever around the internet. But since we got a reply, it's not in play here. Then down here, we've got some statistics. So it tells us how many were sent and received. So we have 0 lost, and then gives us some metrics about the latency or the time it took to get there and back. Okay, so that's pinging an IP address. Let's ping a name. We know that staple.io is up. We can get to the website, and it gives us the IP address. And when we ping a name, there are 2 things happen. The first thing that happens is our computer asks DNS, I need to go to staple.io. DNS responds with the IP address here. It says, okay, here you go. Here's the IP address you need to go to get to Staple. And then my computer says, okay, let me actually ping the IP address. So we got our 4 replies. You can tell it took a little longer, 7 milliseconds on average, and we didn't lose any. So that's ping on Windows. Let's take a look real quick what it looks like in a Linux environment. So we're going to ping, we'll do the same thing. We'll ping our gateway. Now in Linux and Mac, it's just going to keep pinging until you tell it to stop. Whereas in Windows, it's going to ping 4 times by default. You can tell it to ping more or ping forever. Essentially, it still gives us the same information. If I hit Control-C, it stops the ping. And you can see I have 16 packets that were sent in that time, 0 packet loss, the total time it took for all those packets. And then it gives me these statistics, min, average, max, and that's what it looks like. Now, what would happen if we try to ping something that we know is not up? So 253 is not responding, and we can see we get a destination host unreachable. And this is exactly what you would see on Windows as well. So here we can see we sent 7 packets, we received 0. That means we had a bunch of errors, 100% packet loss. Sometimes you'll get, when you have performance issues or issues with certain sites, you might get, some packets are being dropped, and you might see like an 80% packet loss, or the average response times are really high in certain cases. Like up here, instead of being under 0 the whole time, it might jump up to 300 or 1,000 or something like that. That's when you're having connectivity issues to that host. So that is ping, very useful tool when troubleshooting network connectivity. Okay, the next tool we're going to look at is traceroute. Think of traceroute as an advanced ping. What it allows us to do is determine the path a packet would take if you're trying to reach a target. And that'll make a little more sense here in just a second. In Windows, the command is trace RT. In Mac OS and Linux, it's traceroute, and then the destination that you're looking for. And there are some options. We'll go over maybe one of those options when it comes to Windows to help speed things up. So let's start with Windows, and let's run a traceroute to a public IP address. Okay, so we're going to type, we're here in PowerShell, and we can also do this in the command prompt. So actually, we've been using PowerShell. Let's give command prompt some TLC here. All right, so we're going to do trace RT, okay, and then we're just going to trace to staple.io. So what's happening here is it's sending a packet to the first router. That router saying, okay, respond. That packet expired after 1 hop. Then it sent another packet with 2 hops, which went to our second router. Then it sent a packet with 3 hops, which went to the next router after this router, and so on and so forth. And when it responds, it basically asks for some additional information. If the router allows it, it will give it back. Okay. And so what's happening here is it's just sending out multiple packets, waiting for the hop to expire. And when it expires, it just makes note of the last router that that packet came back from. All right. So it took 15 hops to get to this device that's hosting that website. So that's traceroute. Very useful, and it gives you some additional information in terms of how long it's taking. So if you have, let's say, performance issues to a specific location, you can use traceroute to determine, okay, why is this taking so long to get to this particular destination? And you can see in the routing where the problem might exist. So that's Windows traceroute. And let's do the same test in Linux here. And so we're going to trace route staple.io. And again, I'm using a fully qualified domain name here, but you could also use an IP address. So here we're going to trace to the same destination. You can see that that's a little faster. All right, so we got to this location and no more responses. So my firewall at the data center probably saw these probes and decided to kill them. So anyway, it got to the data center, and then after that, there were no responses. You can see after 30 tries, after 30 hops, it stopped. It basically timed out and said, okay, this is as far as I got. You'll have to figure it out from there. Traceroute, very useful in troubleshooting where problems might be. Now, the final tool we're going to look at allows us to check whether DNS is working properly. In Windows, the tool is called DNS Lookup, and in Mac and Linux, it's dig. So let's go into Windows and see what that looks like. All right, here we are in the Windows command prompt, and the command is DNS Lookup, and then the name that we want to look up. So for example, let's look up staple.io. Now, the result has some information in it. The first piece of information is in Windows is the server that we asked the DNS question of. We asked our locally assigned DNS server, which when you see server unknown, what that means is that this particular IP address has no known DNS record or domain name record for that IP address. So it's just saying, this thing doesn't have a name, but it does have an IP address. Then we get a non-authoritative answer that staple should go to this IP address. All right, so we got an answer, that's good. But what does non-authoritative mean? The way DNS works is you have authorities, which is where the record is created, where the record starts, that is. And then you have what are called resolvers. And the job of a resolver is to answer questions when someone asks, hey, where do I go for staple.io? It eventually goes to a result. The question eventually gets to a resolver, and the resolver gives an answer. When that answer is given, it is then cached, typically locally. For example, our router would keep a copy of that answer that would expire after a certain period, and so it would go then resolve again. But that's what causes this non-authoritative answer, which means essentially that I'm using a record in my cache, not directly from the authority. So good, DNS is working. Let's see what it would look like if we asked DNS a question about a name that doesn't exist. So foo.staple.io. So we're going to get an answer from the same server, and it's going to say, oh, sorry, can't find this name. And so that typically means that there is no record for that. Now, it could also mean that there's a problem with DNS. So for example, if DNS is misconfigured, in other words, I have the wrong DNS server configured, I might find something like this. It's just going to hang and then time out. Essentially what that means is that this server that I'm asking, let me back up here just a second. So this question is asking NS Lookup to look up staple, but use this server, 122.2. So that's a way to override your default DNS server. And what's happening here is DNS is having trouble. It's not getting an answer back from this server. Now that's because one, that doesn't exist, but two, if I ask a server that does exist that is not a DNS server, I'm going to get a similar response where it basically is timing out because this server that I'm asking isn't providing the DNS service. Okay, so that is Windows. Let's see what Mac OS and Linux looks like. All right, here we are on our Linux terminal. And the command, instead of NSLOOKUP, which is our Windows command, we're going to use a command called dig. Dig is the default name server or NSLOOKUP tool on both Mac OS and Linux. So it's very similar though. You type dig and then what it is you're looking for. So let's do staple.io again. And we can see it looks a little bit different, gives us some more information. But at the end of the day, it gives us what we want. Here's our answer right here. So staple.io resolves to this IP address, which is the same answer we got on the other machine. Now, if you don't want all this information, because really all we care about at the moment is the IP address, what you're going to do is you're going to type dig, you're going to do a plus short, and then the name. And that will just return our IP address or the answer we're looking for. So let's do that with a record we know doesn't exist. So when we use short, it just returns nothing. If we get rid of the short, then we basically get no answer. The nice thing about dig is it actually goes and tries to find the authority and asks the authority, and even the authority doesn't know. So there's no answer here, which means that record doesn't exist. And that is NS Lookup, very useful when troubleshooting name resolution problems. Okay, now we've given you some knowledge prerequisites, but you're actually going to need just a handful of physical prerequisites, so to speak. The first is a managed switch. Now, most of you probably already have a managed switch, but in order to make use of VLANs, you have to be able to log into the switch and configure the VLAN. So it's a managed switch capable of VLANs. Now, most managed switches, layer 2 switches, which we didn't get into the whole layer thing, but we probably will at some point, is capable of VLANs or creating VLANs and leveraging VLANs. But that is something you will need for this series. You can get them very cheap in our resources section. We have some examples, but most Ubiquiti switches, for example, are managed switches. Netgear, TP-Link, etc. They all have managed switch product line, and they're not super expensive. You can also find, used ones on eBay, etc. But that is a requirement. The next thing you need is a computer with at least one network interface. Now, it's a little trickier conceptually to use one interface, but it's possible, especially with VLANs. But if you have a device that has more than one, like at least two, then that would be easier from a conceptual standpoint. And we'll try to do some examples where we're using only one interface. Now, I'm going to be using something like this device here where it has multiple interfaces. And we're actually going to be virtualizing our firewalls. But again, you don't have to do that. So if you already have a virtual server that you can do virtualization with, then you'll be able to kind of follow along, because with virtual machines, we can add as many interfaces, virtual interfaces, as we want. So it's like having a device with 2, 3, 4, 10, 50, however many interfaces you want. And then the final thing that you're going to need is an internet connection. I know sometimes you feel like you shouldn't have to state the obvious, but you're going to need to be able to download software and test things, and having an internet connection will be very useful. I'm assuming you have an internet connection since you're watching this video, but sometimes you never know. People make assumptions. So I think we'll stop it there for this particular video. Again, check out the resources section below, as well as on our blog post. And thank you for your patience and working through this with me. Hopefully you found this useful and you're ready to take the next step, which is to start actually setting up the network. Have a wonderful day, and we'll see you in the next video.